So welcome to my demo video, and for this video I'll start with the demo for task 1, and we were asked to design a 32-bit decoder circuit using four 8-bit decoders and a 2-bit decoder IC. So the circuit must be at active high. So if it is at active high, there must be an enable pin so that the circuit will work. So I'm gonna turn on the enable pin located right here, and I'm gonna test if the circuit is working. And as you can see from this arrangement, the E is the most significant band and the A is the least significant band. So from E the value is 2 raised to 0 or 1, and from A the value is 2 raised to 4, which is 16. So I'm gonna test the output of the circuit. So enable pin is turned on. I'm gonna turn on E, which is 1. Then I'm gonna turn on D, and for Y3 it must be E and D, meaning 1 plus 2. So the output is 3. For 4, I'm turning the C must be turned on. So Y4 here. For 5, I'm gonna turn on 4 and 1. For 6, I'm gonna turn on C and D. For 7, I'm gonna turn on C, D, and E. And for 8, I'm going to turn on uh, B, which is 2 raised to 3. And for A, the output must be 16, 2 raised to 4. So if all the switches are at logic 1, as you can see, we can see that the output is at 31. So 16 plus 8 plus 4 plus 2 and plus 1 will result to 31 with the enable pin turned on. So if I turn off the enable pin, the circuit will also work whatever switch I will use. So I'm going to move to task 2, and that is another 32-bit decoder using this time 16-bit, which is right here, two 16-bit, and a 1-bit, one piece of a 1-bit decoder IC. So the same scenario, it must be at active high, so the enable pin must be turned on so that Y0 will be logic 1. And I'm gonna check the outputs for the same arrangement. I'm gonna have E for 1, D for 2, for 3, D and E, for 4, it's C, for 5, C and E, for 6, C and D, for 7, C, D and E, for, for 8, it must be B, because again, it's 2 raised to 3. For A, it must be 16, 2 raised to 4. And if I turn on all outputs, still Y31, because all combined, all of them are 31. So still active high. If I turn off the E and pin, the circuit won't work. And this is for my task 2. So I'll move on to my task 3. And this time, it is 74138 IC. And as you can see, the IC must be at active low, meaning if the EN pins are at logic 0, this is where the circuit is working. So I'm gonna test the truth table. So first we have for Y0, A3 must be high, and all outputs are low, A2 to A0. For Y sub 1, A0 must be low. For Y sub 2, A1 must be low. For Y sub 3, A2, sorry, A1 and A0 must be turned on. For Y sub 4, A2 must be turned on. For y sub 5, A2 and A0. For y sub 6, A2 and A1. For y sub 7, all switches must be at logic 1. So this is for my, and sorry, for if I turn on E1, so that it must be that all switches, bulbs are on. If I turn on E2, still the bulbs will be on. So if I turn on E3, which is inverted, oh sorry, which is, no, if I don't turn on E3, still the bulbs must be on. So this is my demo for task 3. So for task 4, the last task, design a 74154 IC, and it must be also at active low. So I'm gonna try to test the design. So at all, so it is active low, right? So at all switches turned off, Y0 is at low. For Y1, it must be A must be turned on. For Y2, B must be turned on. For Y3, A and B. For for Y4, it must be C. For Y5, C and A. For Y6, C and B. For Y7, C, B, and A. For Y8, it must be D. For Y9, D and A. For Y10, D and B. For Y11, DBA. For Y12, D and C. For Y13, DCA, sorry. For Y14, DCB. And for Y15, all switches must be at logic 1. So what if I try to turn on the enable pin? As you can see from the truth table, if I turn on E1, all outputs must be at logic 1. If I try to still turn on both enable pin, the outputs must be still at logic 1. So here it is. So this is my demo for my logically circuit.